Welcome. Today we're going to talk about Docker Model Runner. We'll go over its installation and usage and also how we did our API integration with it. So Docker Model Runner has been out for a while. I'm a little bit late to the party. It's been out, I think, for maybe 6 months. It's a way to run models locally. It's a very Docker-like way of doing it, which I appreciate. It's integrated with Docker Desktop and CLI, which I'll demo. It runs the local models from OCI artifacts. So essentially, it takes a model file, wraps it in a container with some sort of API wrapper and some other goodness to help that model run. And it basically presents containers that have an OpenAI interface to them. They have a curated catalog of models, which is really nice. You get sort of the best of both worlds because it's containerized, but also supports hardware acceleration. You get some good sort of management, logging statistics, inspection capabilities within the user interface. They have a chat app built in, so you can sort of test and validate the models. And as I said, it has an OpenAI compatible API. So the summary of this thing is it's a very Docker container way to run models locally, which I think is a great solution. It's definitely complicated when you're running models locally via Llama or running the gguf files directly with Llama CPP. Just the whole idea of how to figure out the right models and to have the right features that are for the right platform and then be able to get them to run properly. It's a lot more hassle than it ought to be. And this takes all of the legwork out of that. So let's just do a quick demo just to show you sort of how this works. So this is Docker Desktop, which should look familiar. And you have this models menu item, which shows you models that are installed locally. I have a couple here. I have Qwen 3 and Microsoft 5 4. This was a lot easier to install here than it was when I did it by going to Hugging Face and installing it, running it myself with Llama CPP. So you have Docker Hub, which is a registry of model containers. Basically, it's pretty nice, curated. It's not a giant list, but it's kind of the stuff you're probably looking for. And if you want to get details on one, you can click into it and you can see some information about parameters and quantization and a few other things. And you can also choose which version. There's a bunch of different versions you can download. So you'll get latest if you don't specify, if you just go to the top level and hit download from here. But if you click into it, you can see the actual choices that you have and you can pick the one that you want. So that's kind of nice. Also, because these are essentially managed as containers, the way that organizations work with containers and container repositories and discovery and publishing all sort of work with these models as well, which is really nice. So this is the list of models we have installed locally. We don't have any requests to show right now. We have centralized logging, which is kind of nice. If we go into one of these models, so first of all, you see we have a little chat interface, which is kind of nice. It's not, you probably wouldn't really use this, but it is nice to just be able to test, make sure the model's working properly. So the performance of these, I'm running this on a first gen M1 MacBook. A contemporary MacBook would probably run these local models about 5 times faster than this, and it's only going to get faster from there. It also varies a fair amount. I've seen this come back in a couple seconds, and I've seen it take 30 seconds. So we can see that the model's working. If we go into inspect, we can see some details about the model, which is kind of nice. And if we go to requests, we can actually see the requests. These are ephemeral. This isn't like all the requests this model is processed. This is just within maybe the last half an hour, like the last session. I'm not sure exactly how the life cycle is managed. But if we go into this, we can actually see this prompt that we sent. We can see token usage. We can see the detailed request, exactly what was sent. So it's kind of nice, just general way to debug. We can see our token speed, and we can see the response that came back. So it's kind of, it is sort of, especially when you start developing this, and you can use this as a way to intercept your own calls and see exactly what's getting sent back and forth, which is kind of handy. So let's just go into one other thing very quickly. So if you didn't see this models menu item, which maybe you didn't, if you go into your general settings into AI, you'll have this checkbox. I don't remember turning this on. I think it was turned on by default. I might have opted in some beta program. I don't really remember. But anyway, this is the checkbox that turns on the model runner. And then for host side support, which we'll come back to in a minute, this is where you turn that on. This will be turned off by default. You're going to have to turn that one on specifically. So let's go back to, let's talk a little bit about how we actually integrated the Docker model runner into our platform. So we have a TsAgent, which is our TypeScript agent platform. It's a whole suite of APIs and desktop applications and CLIs and various servers to allow you to build and orchestrate complicated agents that use large language models. We support Bedrock, Anthropic Claude, Google Gemini, OpenAI, and then for local models we support Ollama and also what we call the local runner, which just uses Node Llama CPP directly to load gguf files, and then we just added support for the Docker model runner. So the local providers, the Ollama, Docker, Model Runner, and our local provider all use Llama CPP under the covers. They all use the same basic mechanism to run the models. They implement the APIs slightly differently, and it's just maybe worth noting this. This is something I had to dig into when I was debugging some issues with it. So with Ollama, they have a native API, and then they also have OpenAI APIs. And their implementation of their native API is a Golang API that sits on top of Llama CPP. So it's Golang code that's calling the Llama CPP completions directly. And then they use another Golang adapter for OpenAPI compatibility. So we chose to just talk to the native API instead of going through OpenAI. It's not terrible, but if you go to Ollama and you search GitHub issues on OpenAI, it's going to have like 450 issues. So there may be some compatibility issues. I don't know. We just felt like it was going to be safer. And our shims to run these providers are only a couple hundred lines of code anyway, so they're not too complicated. So we just chose to use the native, which is their own Golang wrapper around Llama CPP. And it was a little bit of a pain, but it worked fine. When we implemented our local provider, where we use Node Llama CPP directly, they don't really have a good high-level chat API, but they have some kind of intermediate tool. So we basically had to build our own chat API around their lower-level tools, which involves some knowledge of templates and some other things. So it's definitely more of a hassle. It's way more of a hassle. And with Docker Model Runner, they provide an OpenAI API, and they did it in a different way than Ollama does it, which is they do what's called vendoring the server CPP from Llama CPP. So the Llama CPP project has a server, an OpenAI server, that is a C++ implementation of a web server that implements the OpenAPI interface directly on top of the Llama CPP completions and other APIs. So there are just three different ways to do it. I tend to think that that vendoring server CPP is probably the right way to do it, is staying the closest to the original code and the intent, and there's no adapter in there. It's a little scary just because if there are bugs in there, it's not a whole lot you're going to be able to do about it unless you want to submit a patch to Llama CPP. It would be a lot easier to do that here. One thing that I have found is typically when we do find bugs, they tend to be things that are model specific, where a model interacts slightly differently with the API and causes, complications. And I found that you can almost always fix those from the client side. You can almost always, add extra validation or just be a little more careful about what you're packaging, or package something in a way that's going to be more amenable to all of the clients that might, all the models that might look at it. So we've generally been able to work around problems. We haven't really had anything where we've gotten stuck with a bug in one of these underlying things. But anyway, bottom line, I think these are all valid. I think that the Docker model runner, if I was doing it, that's the way I would have picked to do it. I think that's the cleanest, best way to implement the API around Llama CPP. So our integration was pretty straightforward. As I said, we integrated the Docker model runner as a provider in TsAgent framework alongside all those other providers. So we have just sort of an interface that's pretty small, a few hundred lines of code, shims to basically drive the configuration of the providers, list their models, and chat with the providers. It includes multi-turn chats and tool calls and fairly sophisticated implementation of the providers. So we just use the official OpenAPI TypeScript library. So we just import OpenAPI from OpenAI from OpenAI, just like we did with the OpenAI provider. Just a couple of small tweaks to get that to work. We did find 2 bugs. I consider both of them to be bugs, but they weren't terrible. One of them is even though you don't need an API key when you're using OpenAI with a base URL, as you do in this case, you still have to provide the empty API key. Otherwise, it will throw an exception when you start it up. There was an open issue that was sort of closed as designed. It sort of boggles my mind that it's having a value that's required but allowed to be null or an empty string makes any sense to anybody. But anyway, you have to provide the API key with an empty string in order to get the provider to start. And then there was a kind of an odd case with tool calling. We've seen things like this before. When we call a tool with some of the models via Docker model runner, you'll get back a tool call that has a null content value. And typically, it's sort of up to the model whether it wants to provide content or not if it's calling a tool. Sometimes the models will provide content that's sort of explanatory about the tool call. Oftentimes they don't, especially with the smaller models. But anyway, in this particular case, the model returned content null, and when we piped that back into the conversation history, the model blew up because it can't handle null as a content value. So that's a little bit of an odd API implementation, that it emits something that it can't accept as content history. But the fix for that was just to basically, if we ever got a content null, we just make it an empty string. So that was super simple. So this whole thing was probably 20 minutes of screwing around and debugging and looking at GitHub issues just to make sure that we had a clean, correct solution that would work, and doing testing. But other than that, everything worked out of the box. Model listing worked, multi-turn chat, completion with tool calling, everything worked. Like it was super easy. And I'll just show you a little bit of, so the way we did this was we basically copied and pasted our OpenAI provider and renamed it Docker, and then we did a big search and replace of everything that said OpenAI to say Docker. We did remove some things in our OpenAI provider. We have some things to filter out models that are not text completion models, and a few other things, but we kind of cleaned it up a little bit to make this one simpler. But basically we specify the model configuration, and then when we start the model, this is all you really have to do that's different. So as I said, normally you would use OpenAI and you would just give it your API key, and it would find the commercial endpoint, API endpoint. In this case, we pass an empty API key to keep it from blowing up, and then we pass a base URL which points to where we're running the model locally, not the model, where we're running the model runner locally. So this will allow you to have access to all the models. And then everything else is pretty much the same. It's all the same kind of cut and paste, and I'll scroll down here. And I guess the meat of this is really like something like when we do a chat completion. This is about as complicated as it gets. So this is just calling the OpenAI chat completion, just exactly like we did with OpenAI, same exact parameters where we pass it in the model name, our array of turn messages, tools, some parameters. Everything works kind of the way you'd expect. So super clean. I was kind of figuring this would be like a full day project, and it was probably an hour end to end, which was super nice. So let me, I'll go back and show you a couple things. So back here in your AI settings, if you want to use an API, if you want to talk to the API locally to talk to these Docker model runner models, you have to enable this host side TCP support, choose a port. You can set up course headers if you want. So this will actually turn this on so that now this port will be available. And then I'll show you what it looks like in the product. So in the product, we now have our list of providers. So we now have a Docker provider that's Docker model runner, and it's able to list the available models that it has. I didn't really show that, I guess, but like when we're back over here, like these are the models that we have installed. And when we go into our product and we enumerate the models via the API, you see the same models there. So when you configure it, this is what it looks like when you come in to begin with. You're going to point it to that localhost endpoint. And you're going to need to do /engine/v1 at the end of that. I tried a few variations of that. This is the only one that seems to work reliably. Anyway, pretty straightforward. So you're going to use your localhost with the port you set up, engines v1. And then when you do that, you're going to see that you have access to these models. And then once those models are available, then they'll be available here. So when we go to pick our model that we want to use, we can see that we have access to those OpenAI Docker models. So let's just do something very simple here. Again, this is I would consider to be a fairly slow machine for doing local inference. Okay, so we got back our answer. So one of the interesting things here is we can go back in here and we can look at this. So we can go to requests. Oh, so let's just take a look at, so now we can see, unlike our last request, we can see a lot more token usage. And the reason for that is that when we call via our application, we're going to pass in a bunch of relevant contexts as messages. So we're going to give it a system prompt and a bunch of other stuff. So this is the call that we just made from our API. Actually, let me go and look at the response part of that. So yeah, we can see the response, and there's the response we get back from the model. So it's kind of nice that we can use this as a tool to inspect the things that we're actually doing from our API calls. And then let's do a slightly more complicated case. So we have a bunch of tools installed, including tools to access the local file system. And we have some context matching that will take that query and figure out which tools are relevant, give those tools to the model, and then the model should be able to call those tools and provide us an answer. So that's exactly what happened. So we said, what directories can you see? And the model, again, which is this Qwen3 latest running via Docker, called this file system list all directories tool, and it told me what directories I can access. So it worked exactly the way you'd expect it to. Again, if I go back here, so this will be interesting because now you can see that I have two calls that are both the same prompt, because what happens when you do a tool call is you make the call and then it replies back with a request to run the tool. You run the tool, you provide the result of the tool, and then you run that back through. So you get essentially a second request. Call that multi-turn processing. So here we can see this request. And in this case, we can see that we have a tool call that it tried to make, and then we have the result of that tool call. And then they're correlated with this ID. So this is what it looks like when the model makes a tool call. But again, we can kind of see that right here, which is sort of cool. But yeah, I guess that's the end of the demo. I'll say it was pretty clean and pretty easy. It was definitely the easiest one of these providers that we've integrated yet. Just a couple small tweaks to get it to work properly using OpenAI. The models work. We've tried a bunch of different models. Having that ability to kind of debug them through the Docker provided user interface is nice. It's just like, I don't know, it's just a much better, nicer solution. I think Ollama was probably our preferred way to do it before, although we needed a way to run local models without it. Docker is definitely my favorite way to run them now. And I'm a big fan of local inference, and I think we're going to see more and more of this as the local models get better and more powerful, and as the hardware gets better and more suited to doing inference on the local machines. It's just going to make a lot more sense to do local inference. Anyway, I'm super happy with Docker Model Runner. Give it a try if you haven't already.